Hey there, students. Welcome to Psych 653 Lab. I hope you had a wonderful winter break and are ready to start up again on our labs modules. I'm excited to teach this semester. So today what we're going to be doing is talking about Modulo 1, which is nested in incomplete designs in ANOVAs. So just a little review of what we'll be talking about on our objectives. So first we're going to talk about reviewing what an ANOVA is, because I know it's been a while. I don't anticipate you running ANOVAs during your break. What a nested design is. Then we're going to view some of Kevin's nested designs and talk about them. Then we're going to give you a description of the data set that we'll be working with. Then we're going to use the aggregate function I'm going to teach you about the aggregate function because you saw it in lecture before, and then we'll go ahead and do our classic totem tutorial. So let's go ahead and start off by reviewing kind of what ANOVAs are to start with. So an ANOVA evaluates how a continuous outcome variable varies across levels of categorical predictors. So remember, you have categorical predictors and a continuous outcome variable. You have three essential components that you need to look at when you run an ANOVA. First is the sum of squares, which is the sum of the square deviations from each individual value in the mean. Then you get the mean square, which is the average distance that those values deviate from the mean, essentially. And then lastly, you get the F statistic, which is a ratio of model mean square to the residual mean square, which is just the MS explained divided by the MS residual, which gives you an F value. And we use that F value to obtain our P value to determine significance or not. So start off, so when you look at your ANOVA table, here's your sum of squares, which is just the sum of the square deviations from individual values in the mean. To get the mean square, you just divide this, the sum of squares, by the degrees of freedom, which will get you your mean squares, same with the residual as well. Then to get your F value, you divide the mean squared explained over the mean squared residual to get this 3.5625, and use this by looking it up into a P table, on an F table, in order to get the P value and indicating whether there's significance in here, indicating whether there's significance or not. Here there just so happen to be significance from our model. So next thing I want to talk about is what is a nested design. A nested design, otherwise known as a hierarchical design, is when factors are nested within one another. A nested ANOVA is a particular type of nested design, and which is also called a hierarchical ANOVA, is used to evaluate the differences within variables while taking into account the nested structure of the data. So let's go ahead and just take a quick look at what this is showing us here, this image here. So we have our population, but we get things split up into three organizations. And within each organization, there's three different people. However, the people differ from one organization to the next. So those of you maybe work in IO psychology, this is probably pretty essential if you wanted to compare organizations. You're probably going to be using nested structures quite often. But as you can see, people differ from one organization to the next. So we have to use special abilities where we say we can't necessarily compare organization 1 to organization 2 and organization 2 to organization 3 because there's different people in each organization. So running an interaction between these organizations wouldn't quite work. So let's go ahead and look at the way that Kevin is showing you nested designs. So let's look at the first design that he shows you, in which he shows you that hospital 1, hospital 2, drug 1, drug 2, drug 3, drug 4. So H is hospital, D is drug, and then C is condition. So we have conditions 1 through 12. So within this design, we can say that drug is nested within hospital because the drugs differ between the two hospitals. As you can see, we have drug 1 and drug 2 within hospital 1, and drug 3 and drug 4 within hospital 2, but they don't cross at all. So there's never drug 1 present in hospital 2. Next, we can say that condition is nested within hospital as well in this day because conditions differ between the two hospitals. As you can see, we have conditions 1 through 6 in hospital 1 and conditions 7 through 12 in hospital 2. However, none of the conditions cross over from one hospital to the next. And then lastly, we can say condition is nested within drug and hospital because the conditions differ between the two drugs within the hospital. As you can see, drug 1 only has C1 through 3, drug 2 has C4 through 6, drug 3 has C7 through C9, and drug 4 has C10 through C12, but they never actually cross. So, as you can see, we have what is called a fully nested design in this case. With that, we can't run any interactions within this design because nothing interacts with each other. None of the variables cross with each other in any way. So if we wanted to run this in R, the way that our regression model would look is Y regressed on hospital plus hospital within drug plus drug within hospital plus condition within drug within hospital. And those slashes indicate that it's a nested structure. And you can't run any interactions in this design. So keep that in mind. If you see this somewhere else that you say, oh, well, I can't run an interaction, I can only run a nested design. And we'll be able to see later when we're creating box plots why the interaction isn't possible. So let's look at Kevin's design number 2. So as we can see, again, we're working with hospitals, drugs, and conditions. So the first thing is we can see that drug is nested within hospital because the drugs are different between the two hospitals. We see drug 1 and drug 2 apparent in hospital 1, and drug 3 and drug 4 are apparent in hospital 2, but they're not apparent in the other hospitals. They don't switch at all. Next, we can see that condition is nested within hospital in this data because conditions are different between the two hospitals. So if we split it by hospital, we see that within hospital we only have drugs conditions 1 through 3, and in hospital 2 we have conditions 4 through 6 only. So because they differ between hospital, we can say that they are nested within hospital and no interactions can be run between the two. Lastly, we can say that condition is not nested within drug because the conditions are the same between the two drugs within hospital. So when we separate this by hospital, to start with, we can see that, oh, drug 1 and drug 2 both experience conditions 1 through 3 in hospital 1, and drugs 3 through drugs 4 both experience conditions 4 through 6 in hospital 2. So therefore, condition is not nested within drug. And I kind of play it out for you. So within this, you can run one interaction within this design. It's the drug nested within hospital by condition nested within hospital because the conditions are the same within hospital. So again, remember, C1 through 3 is present in drugs 1 and 2 when we nest it within hospital, and then C4 through 6 are available in drugs 3 and 4 when we nest it within hospital. And again, the slashes indicate a nested design. And notice how every single time that I run the drug within hospital, every time I mention drug or I mention condition, I have to nest it within hospital within our design. And you'll see what we're doing when we actually run into the R code as well, when we start doing our coding tutorial. And then lastly, I wanted to show you one last one, which is design number 3. So here we can say that drug is not nested within hospital because the drugs are the same between the two hospitals. So we see drug 1 and drug 2 apparent in hospital 1, drug 1 and drug 2 apparent in hospital 2 as well. So therefore, drug is not nested within hospital. Next, we can say condition is not nested within hospital in this data because the conditions are the same between the two hospitals. So drug 1 and drug 2 both have conditions 1 through 3 within them. Drug 1 has conditions 1 through 3. Drug 2 has conditions 4, 5, 6. I'm sorry. Conditions. You can see that conditions 1 through 6 are apparent in hospital 1, and conditions 1 through 6 are available in hospital 2. However, this is where I was getting a little confused before, but now I can say condition is nested within drug because the conditions are different between the two drugs. So as we can see for drug 1, C1 through 3 is apparent within drug 1, and then C1 through 3 is apparent within drug 2, and within drug 1 again. However, drug 2 only has C4 through 6 and C4 through 6. Therefore, it is nested within drug because our conditions are different between drugs. So with this model, you can run 2 interactions with this design. You can run the hospital by drug and hospital by drug and hospital by condition within drug. So your regression output would look like Y regress on hospital plus condition nested within drug, because always every time you mention condition you need to nest it within drug, plus hospital by drug plus hospital interacting with condition nested within drug. And that's really all there is to the different designs that Kevin gave you. I think that covered most of them. We can go over in lab if you have another one where we can talk about it as well. We'll talk about any other nested designs that you come up with. But now I would like to talk about what the dataset description is. So this demo uses 114 patients who participated in a study to evaluate the effects of different drugs on treatments, on conditions, on health. So our overall research question is, does patient health significantly vary across hospitals, drugs, and treatment conditions? So we're still using the H, D, and C, so hospital, drugs, and condition. We have an outcome variable, which is just Y, and this Y stands for a proxy for health. The values can range from 1 to 15, where higher scores indicate better health. And then lastly, our predictors are hospital, drug, and condition. So this is the structure of the data that we'll be working with today. And what I want you to do is actually kind of pause this video and see if you can determine what the actual structure of the data is. What's nested within what? Where can I run interactions within this data? And have we seen this before? You can refer back to the previous slides to kind of determine where it is as well. But just go ahead and pause the video right now. Okay, so if you pause the video, then we'll kind of see if you're correct. So here we can see that drug is not nested within hospital data because the drugs are the same between the two hospitals. As you can see, drug 1 and drug 2 exist within hospital 1. Drug 1 and drug 2 exist within hospital 2 as well. Next, we're going to say condition is not nested within hospital in this data because the conditions are the same between the two hospitals. So we have C's 1 through 6 in hospital 1 and C 1 through 6 in hospital 2. So drug is not nested within hospital. We can run an interaction between the two. However, condition is nested within drug here. So you've seen this before because the conditions are different between the two drugs. So as we can see, drug 1 only experiences C1 through 3, C1 through 3, and drug 2 only experiences C4 through 6, C4 through 6. So as we can see, condition is nested within drug, and so we can assess if there's an interaction between the two. I'm sorry, we can't say that there's an interaction nested between the two. My apologies. And then lastly, before we get into the coding tutorial, I just wanted to kind of break down this aggregate function for you because you saw it in lab and I don't think there's much explanation associated with it. So I just wanted to show you, and we're going to be using it today. This is equivalent to using the group by and summarize. If you feel more comfortable using group by and summarize, by all means, go for it. But essentially what I'd like to show you is that, look, there's a function called aggregate, in which first thing you indicate within this is the continuous outcome variable. So in our instance, it's y. You do comma by equals list. I don't want to get into detail as to why you need to indicate list, but what essentially we're doing is converting it to a list so that we can do some special operations on it. The red here is where you name the variable. It can be whatever you want to call it. I called it hospital here. I usually just call it the name of the variable that I'm trying to get the aggregate of. Then you indicate the data set, and then whatever your grouping categorical predictor variable is indicated here. Then you end your parentheses and comma, and then you do whatever desired descriptive function you want there. Usually it'll be mean. You can do the standard deviation, you can do the median, whatever you want. But what this will do is it's essentially just split things out by hospital on the outcome of y. Okay, so let's go ahead and get coded. But before we get started, I just wanted to remind you that this is what our structure of our data set is going to look like, okay? Remember, drug is not nested within hospital, condition is not nested within hospital, and then condition is nested within drug. So try and keep that in mind when we're running this today. Okay, so let's go ahead and start coding. Okay, so before we get started, I'm going to go ahead and create a new folder because we are starting with a new class, and I'm going to name this folder sci_653. So whatever way that you decide the best to house your data, but just remember we're going to be creating individual projects for every single unit within this folder, okay? So I created a new folder, it's blank, and we're going to be filling it up throughout the semester, okay? So the first thing I'm going to do is I'm going to go ahead and get here. I'm going to zoom in a little bit for you guys. There we go. I'm going to go ahead and create a new project, so new directory, new project, and we're going to make sure that this is saved to the right place. So desktop, Sci653, open. our directory name. I'm going to name this module 01 and then create project. And let's just go ahead and confirm that that worked too. So I'll go ahead and just check within our Psych63. Yep, we have module 01. We have our project file saved in there. Next thing we're going to do is go ahead and go into the data set. So let me just go ahead and get to Canvas here. So we log into our Psych63 Canvas, go to modules, and then we're going to go ahead and go to module 1 lab, and it's going to be the nested demo.csv. So we'll go ahead and download this. And let's go ahead and just take a look at our data set as well. So look, we have our outcome of Y. We have hospital, drug, and condition. Notice how these are all just character variables. That's totally fine. We're just grouping variables. It don't have to be actual numbers. We'll have R handle all that for us, and then Y is your only actual continuous variable within here. So I'll go ahead and do File, Save As, Browse. I'm going to go ahead and save it into Psych63. I'm going to go there. I'm going to remove this one here so it looks a little nicer. Press save. There we go. Okay. And let's go ahead and let me load up some notes here. Okay. And then let's go ahead and get started. Okay, so we got it loaded up in here. So I'm going to go ahead and start a new R notebook. If you remember how we did that before, we just go up here to this paper sign and do new notebook. We're going to delete all this unnecessary text. And let's go ahead and name this title. Let's go ahead and just name it Nested ANOVAs. And we'll go ahead and create a new table of contents. Remember, I'm a pretty big fan of this. So you do enter, tab, colon, POC, colon, yes. And I'm going to go ahead and just save this real quick so that we can have something here. So I'm going to name it Module 01 Notebook. There we go. Save. Perfect. Okay. So it looks like we're set up and ready to go. So remember, the first thing that I always like you to do is we like to detail our progress a lot using the hashtags to create these headers a lot. So first thing we always want to do is load our libraries. Load libraries. Oops, otherwise known as your packages. So you go to Insert, R, and then we're working with the executable R code here. So there shouldn't be any new packages that you need to download, but our first one is going to be library, psych, and then library, tidyverse. So let's go ahead and run this. And let's see here, it takes a little while. There we go, perfect. I'm just going to run that again so that we can clear up some space here. All right, so we got two packages that we're going to be using today. Next, let's go ahead and import data. So go insert R. So we're going to be importing the nested demo.csv. Remember, it needs to be named exactly as that is here. So the first thing we do is we're going to name our object. I'm going to name our object nested demo. Then we use an assignment operator, which is that less than symbol and a dash. Then we're going to use our function called read_CSV. And in quotation marks, we're going to name it nested with a capital N _demo.csv. So if we run that, it should appear as a new object up here, assuming we named everything correctly. Looks like it did, so we go ahead and take a look at it. So it looks like how we had it before, where we have Y, and then we have hospital, drug, and condition. There's 114 observations. Okay, looks like we've got our data set loaded in. Okay, I'm just going to go down some more. So let's go ahead and just get the variable descriptors here. Okay, so remember, one of the best ways to get our variable descriptives is through the describe function from the psych package. So I'm just going to do hashtag get variable descriptives. Okay, I'm going to insert a new R chunk. We're going to use describe, and we just name the data set nested. I hope this is all starting to come back to you. I know it's been a little while since you've been on to R, but hopefully this comes on to you. So the main one that we're going to focus on is actually just our Y variable. So the mean is 8.75. Remember, that's a proxy for health. So So on average, they're scoring from 1 to 15, 8.75, so around in the middle. Standard deviation is 2.91. We're not going to really concentrate on hospital drug condition. What it did is it went ahead and factored it for us and did some calculations, but we don't necessarily need to look at those. But what this could tell us is, okay, yeah, there's some things here. There's 6 different conditions, there's 2 drugs, and there's 2 hospitals. And remember what our grouping structure was before. I don't have it quite up here, but remember we had I believe it was hospital drug wasn't nested within hospital, condition wasn't nested within hospital, but condition was nested within drug within this data set. So let's go ahead and we're going to go ahead and use this aggregate function in a bunch of different ways now. So we're going to calculate the mean values for hospital, the mean values for drug, and the mean values for condition. And then we're going to go ahead and visualize that as well by getting the box plots of each of those. So let's go ahead and start by do hashtag calculate the mean values of Y. And then we're just going to do hashtag by hospital. So we'll go ahead and do insert a new R chunk. We're going to go ahead and we're going to use that aggregate function that we learned about before. Like I said, if you don't feel comfortable with this aggregate function, you feel more comfortable using the group by and summarize, that's fine. This aggregate function really just sets it so that it's one line of code. It's a little bit simpler. Once you kind of get used to it, it gets a little bit easier to use. I like it a lot. I'll use it sometimes over group by and summarize, but this just does it all in one line of code. All right, so we use our function, which is called aggregate. Then we're going to go ahead and do nested underscore demo. That's the name of our data set. $sign, so we're digging within the data set. We use our outcome variable, which is Y. That to be a continuous outcome variable, comma. Then we set by equals list, and remember that list is just an essential part of how we do this. Name the variable that you want to do it by. I'm going to name it hospital, and we're going to dig into our nested demo data set and get hospital, comma. Then we indicate the function that we want to do this by. So we'll do the mean. You can set in a standard SD in there for standard deviation or median in there, whatever is most comfortable for you. And I think I ran this correctly. Yep, looks like I ran 2. So as we can see, there's not really that much of a difference between hospital 1 and hospital 2 as far as their mean values, right? It's 8.75 and 8.73. So the hospitals don't vary by very much. So let's go ahead and do the same thing, but hashtag by drug. So we're now going to be calculating the mean values of Y by drug. So let's go ahead and use our aggregate function. Then we're going to do nested underscore demo Y, comma, by equals list. Then we named the variable, so I'm just going to name it drug equals nested. So we're going to dig into the nested demo data set, and then we're going to do it by drug, comma, mean. Okay, so we go and run that. There we go. And again, we're seeing that really, it doesn't vary much between drug. Okay, then let's go ahead and run it by condition, which we have 6 different conditions. Okay, so we'll do hashtag by condition, and then we'll do insert R, and we'll do aggregate, aggregate, nested demo is our Y variable, comma, by equals list. We will name this condition equals nested demo, into there, get the condition, comma, mean. And then we'll go ahead and press play there, and there we go. And as we can see, it looks like they don't vary too much across conditions. Condition 5 and condition 6 seem to be the most different out of all of them, but again, it's not too much of a difference between how they vary on our outcome variable of Y. essentially. So we can see that condition 5 is on average 9.78, whereas condition 6 is on average 7.7, and the rest of them falling within the 8 range in here. So again, there's not much of a difference. We're not expecting to see much of a difference between these, but we'll go and do this. Now I'd like us to visualize the data. So we'll do hashtag visualize the data with box plots. Okay, so let's do hashtag, let's do double hashtag here, box plot of Y by hospital. And this is where you're going to see where the condition, the matter of being nested within a structure really makes a difference when you're looking at these things. So remember, what we use to create box plots is that ggplot. And remember, there's 3 essential things that you need with ggplot. You need the function, or sorry, 4 essential things. You need those functions, ggplot. You need your data set. You need your aesthetics, which is something to map it onto, and then you need your geom layer. So here we're going to set it to an aesthetic of either Y, because we want it to be vertical box plots, and our geom layer is going to be a box plot layer. So we do ggplot, parentheses, nested demo, which is our data set, nested underscore demo, comma, we set in our aesthetic, we're going to do Y equals, and the outcome variable is just a capital Y. We're also going to go ahead and set a color here. Color equals hospital. Okay, then we do plus, and we use our geom layer, which is going to be geom box plot. So remember how this works. So ggplot, we indicate our data set. We set our aesthetic where we say, hey, we want it to be set to a Y variable, and that Y variable is going to be a capital Y for the Y data set. So remember, capital Y within our data set, and then we're going to color it by hospital, which means it's going to kind of separate it out by hospital, and then we're going to get a box plot. So let's go ahead and run that. There we go. So it looks like, as we expected, they're not too different from each other. Then we're going to go ahead and do a ggplot, ggplot of Y by drug. So let's do hashtag box plot of Y by drug. So let's go and do R. We're going to do ggplot. Set our data set, which is nested underscore demo, comma. Then we will do our aesthetic, and we're going to map a Y equals Y. This time we're going to comma color it equal by drug. So drug plus geom box plot. There we go. It should work out here. Oh, what did I do wrong? Oh, forgot to put my parentheses there. Perfect. Now we should be good. There we go. Geom box plot. So again, it doesn't look too different. Now let's go ahead and facet this by, we're going to go ahead and run this, but we're going to facet it by hospital. So I'm actually just going to go ahead and copy this actually. Copy. Hopefully it'll be a little bit, it's easier if we just copy things. So what we're going to do the same exact plot we did here, but we're going to facet it by hospital now. And remember how facet, I'll remind you how facet works. So let's do hashtag box plot of drug of Y by drug faceted by hospital. Okay, so we're going to insert a new R chunk. So what we're going to do is just going to call and paste, copy and paste this, plus we're going to do, remember it's facet underscore wrap there, and we're going to use a tilde to indicate that we want it to be faceted by hospital. Okay, so there we go. We go ahead and run that, and there we go. Now remember, drug was not nested within hospital, so we can run an interaction between these two. So notice these box plots are the same color. So we see drug 1 apparent in hospital 1 and hospital 2, and drug 2 apparent in hospital 1 and drug 2. So if we wanted to, we could run an interaction between hospital and drug with this data set. However, when we start running into conditions, start faceting by condition by drug and by hospital, we're going to see where this actually differs and where we're not going to be able to run an interaction. So we're going to be seeing that pretty soon. But first, let's go ahead and do hashtag box plot of y by condition. So we're going to start off by just doing the box plot of y by condition. Then we're going to facet it by drug, and then we're going to facet it by drug and hospital to see what's going on. So remember, ggplot. So we're going to do ggplot, parentheses, nested underscore demo, comma, we're going to set our aesthetic y equals y, comma, color equals condition. We have 6 conditions, so we're going to have 6 different plots here. Geom box plot. Okay, so this should run appropriately. Go ahead and run play. There we go. So we have 6 different conditions, and we see that condition 5 and condition 6 kind of varying the most. Now what we're going to do is see what it looks like when it's nested within drug. Okay, so I'm going to go ahead and copy and paste this. Copy this because we're going to be changing just one simple thing where we're going to facet it by drug. All right, and we're going to see, as you can recall, our condition was nested within drug. So we're not going to be able to run an interaction, and you're going to be able to see why when we run this box plot. So let's do hashtag box plot of y by condition faceted by drug. I'll put in here it is nested. Or I'll put condition is nested within drug. Condition is nested within drug. Okay, so let's go ahead and I'm going to go ahead and just insert a new R chunk. I'm going to paste what we had before where we're coloring it by condition, but we're going to go ahead and add that facet underscore wrap. And we're going to use it. Remember, facet wrap by using a tilde. We're going to facet it by drug. And then when we run that, okay, so now we have all of our conditions, but as you can see, the box plots aren't the same across drug 1 and drug 2. So we can't really compare drug 1 with drug 4. There's no interaction possible within here. So if you run something faceted by like drug or something else and it appears like this, that means, oh, nope, can't run an interaction between the two because there is no interaction present within these. So this is because condition is nested within drug. And then we're going to build one more box plot, in which, remember, condition is not nested within hospital, but it is nested within drug. So what we're going to do is we're going to facet wrap it by 2 variables now. Okay, so what I'm going to do now is I'm actually going to go ahead and we're going to do hashtag box plot of condition faceted by drug and hospital. And here we're going to see why we can compare across hospital, but we can't compare across drug. So I'm going to go and insert a new R chunk. I'm going to go ahead and copy and paste what I had before, which color by condition. Then we're going to do another facet wrap. Now, when you facet wrap by 2 variables, it's a little bit different in the way you do it. Instead of a tilde, we're going to do vars, parentheses. We're going to facet wrap it by drug, comma, hospital. That's going to allow us to facet it by 2 ways. I think there's a way to do it with the tilde, and then you use a plus sign in here, but we're going to just learn how to use the vars because that's the way that I kind of learned how to do it. But if you want to ever facet wrap by more than 2 variables, you can use the vars, and then whatever variables you want to. You can facet wrap it by 3 variables, 4 variables, however many you need is necessary. But here, when we're facet wrapping by 2 variables, use the vars, parentheses, and then you list the variables you want to facet wrap by separated by a comma. And then we go ahead and run that. Okay, so now we've got our facet wrap by drug and hospital. So as you can see, is drug 1 is on the top, drug 2 is on the top, and then on the left side is hospital 1, and on the right side is hospital 2. So look, within drug 1, we can compare the conditions by each other, assuming it's nested within hospital here. So we're saying, yeah, drug 1 we can compare across hospital here. Drug 2, we can compare across hospital 2 as well. But we can't compare drugs, drug 1 and drug 2 within each other, okay? So notice we got C1 through 3 up on top here, and then C4 through 6 on bottom here. But we can't compare these with each other at all. So that's really what I wanted to get with these visualizations, is what you are able to have an interaction between and what you're not. Remember, we couldn't have an interaction between drugs because they're not the same across drugs. I know that's apparent with the visualization we saw earlier, but I hope it drives it home with these box plots. Okay, so now that we've done all our visualizations, we're finally going to run our ANOVA. Now, like I said, this isn't something that you need to do. You don't need to run all these visualizations, but I think that it helps drive it home what we're doing. Now we're going to go ahead and run the actual ANOVA here, okay? So these ANOVAs really depend on what it is that your nested structure looks at. You need to make sure that you have the correct nested structure for you to be able to run these correct ANOVAs. So let's go ahead and hashtag conduct the ANOVA. Okay, so go ahead and insert a new ArcDoc, and I'm going to go ahead and actually, if you don't mind, I want to go ahead and just open up my PowerPoint from before. So let me just get this over here, and I just want to be reminded as to what the nesting structure of our data is. Okay, this is the nested structure of our data. So remember, drug is not nested within hospital here. Condition is not nested within hospital. However, condition is nested within drug. So every time we mention condition, we need to mention the nested structure of drug as well. So remember, this is what our nesting structure looks like here. So what we're going to do is we're going to name this, it's going to look just like a classic ANOVA, except you're going to be using slashes now to indicate things are nested within each other. And we'll be using interactions. So I'm going to name this mod 1. We're going to use the LM function. Then we use Y regressed on. So Y is our outcome variable in here. Remember, in our data set we had Y. So that's our X, whatever your outcome variable is. Y regressed on hospital plus drug plus, remember, we want to do condition, but every time we mention condition, we need to actually nest it within drug. So drug, so it's nested within drug condition plus, we want to be able to run all of our interactions. We can run an interaction between hospital and drug because they're not nested within each other. So hospital by drug plus we want to run hospital, and we can also run the interaction between hospital and condition nested within drug. So drug slash condition, and we got to make sure that's correct. Within our data equals nested underscore demo. Okay, so let's just review what we did here. So we did mod 1, LM, Y is our outcome variable. So we know hospital is the top tier, so hospital plus drug. Drug is not nested within hospital. However, condition is nested within drug. Then we were able to run the interaction between hospital and drug because they're not nested within each other. Then we can run the interaction between hospital and condition, which is nested within drug. Okay, so we run that. If we run this, we're going to get a new variable called a new object called mod1, just the list of our linear regression model. And in order to output that, we're going to use the ANOVA function. So it's going to be ANOVA mod1. Okay, and then we're going to get some output from this. So let's go ahead and run this. Okay, so we have a few things here. We have our coefficients first for hospital. We're saying nope, hospital is not significantly. So saying the outcome of Y does not significantly differ across hospital. And same with drug. So our outcome of Y does not significantly differ from drug. So the hospital, first of all, this is the, I'm going to go ahead and do this. This is our box plot for the hospital. We're saying, do these vary from each other? We're saying, nope, they don't. Then we're saying, do these vary from each other in our drug? And we're saying, nope, they don't. And then we're going to keep comparing these box plots with each other, okay? So then what we're going to say is, is there an interaction? So this is where R gets a little bit confusing. A colon within R can mean two things. It can mean the interaction between them or the nested design between them. So here, this colon doesn't mean an interaction. It means condition within drug. So we're saying, does the conditions which are nested within drug differ from each other? And we're saying, nope, they don't quite differ from each other. Then here, this is where you need to know a lot about your model. We're saying, is there an interaction between hospital and drug? So it's not the nested design. Unfortunately, R makes it quite confusing, and I wish they could use a slash or something like that to indicate that this is an interaction, but this is the actual interaction between drug and hospital. So we're saying, is there an interaction between drug and hospital? And it's saying, no, there's not an interaction between drug and hospital. Then the most confusing of all of them is this one that we're looking at here too. So we're saying, is there an interaction between drug and the nested design between is there an interaction between hospital and the nested design between drug and hospital? And it's saying, no, it's not. Condition and hospital don't interact with one another. And notice again how we didn't do an interaction between drug and condition because it's a nested design. We can't do that interaction between drug and condition. So as we can see, it's mostly a non-significant model. It seems like the outcomes doesn't vary across hospital, drug, or condition within our model here. So we don't really need to do any sort of we don't need to do any contrast or anything like that, but what we are going to do is I'm going to go ahead and show you how to get the effect sizes. So remember, to get effect sizes, all it is the SS effect over the SS total, right? Which is for that eta squared effect size. So let's go ahead and do hashtag get eta squared effect sizes. Okay, so let's go ahead and start off by doing hashtag get it for hospital. So the way that we do that is we do insert R, then we do our sum of squares effect, which is 0.02 divided by our sum of squares total. So it's 0.02 plus 0.01 plus 39.30 plus 0.08 plus 0.75 plus our residual plus 913.47. So if we go ahead and run that, it's going to be a very small effect size. We have a very small effect size associated with this. Yeah, okay, I got the correct answer. So then we're going to go ahead and get the effect size for drug. Then we go ahead and create a new R chunk. And what we're going to do is it's going to do 0.01 divided by the total. And to get the total, I'm actually just going to go ahead and copy and paste this because this is the same. The total is the same across this. So we're going to go ahead and copy and paste that. And this is also going to be a very small effect size. Yep. So remember, it's in scientific notation. So that's 0.00001 is our effect size there because you have to bring the decimal over 5 places. Then we're going to do hashtag drug or condition, which is nested within drug. So we indicate that it's nested within drug. Insert an R chunk, and that's going to be 39.30 divided by our SS total. Copy and pasted it from before, which is 0.04. Remember, these are expected to be pretty small effect sizes. This seems to be the largest out of all of them, but it's still pretty small to negligible effect size. Then we're going to do the hospital by drug. So hashtag hospital by drug. Insert a new R chunk. Then that's going to be 0.08. So 0.08 divided by the total. So press play here, and that's very small again. And then we're going to get our final interaction, which is hashtag hospital by drug condition, which is nested within drug. So hashtag. So remember, I know it's confusing, but this is the interaction between hospital and condition nested within drug. So this colon here is really a slash, and that's going to be 0.75. 0.75 divided by our total. It's going to be right here. Here we go. And that's about it. So we went ahead and we found the, I'm going to go ahead and save here. We found the effect sizes for each of our coefficients. So it wasn't significant, but it was still a good idea to go ahead and find our effect sizes for, especially if you have a significant coefficient, you would find your effect size. So that's what we did. So we found the effect sizes. This is the model we ran. So I want you to, when you're running on your assignment, you're going to make sure that it's a correct nested structure, or you have the correct model associated with your structure. So you have to look at your model and say, okay, are there any interactions that are present within my model? Can there be interactions? What's nested within what within the model when I run it, when you run it on your own assignment? So I'm going to go ahead and end the lecture there. So we're going to do that. I'm going to go ahead and tell you that there is an assignment for you. So we go to modules, and then we go to module 1 lab. There's an module 1 assignment. .pdf, and you're going to use the nestedpractice.csv for that. So this is what your assignment looks like. Please let me know if you have any questions at all with it, and we'll go ahead and get started. So remember, this is what the nested structure of your assignment is going to be. It's going to be different than the nested structure of what we did before. All right, thanks, y'all. Have a good day.